Okay, just to clarify, the exam is posted. It's not open yet. You will be able to enter after 1 o'clock today. And you will have until Tuesday at midnight to submit. You're going to solve the problems in a quiz here, quiz-like format here. And then here you're going to upload a PDF file. And if you did use Excel, you can load that too, but the PDF file is the priority. If you do not have a PDF file, you do not have evidence for your problems, and you will get a 0 if you do not upload it. Oh, what did I say here? No, I didn't say it here, but you must submit your handwritten document, okay, to prove that you've solved the problems in your own handwriting. I guess I can add that too. Okay. So tell me, where should I start today? How are you doing in your review? Just going to add one more comment here.
Profesora, ¿me escucha?
Yes, sí.
Ok. Yo tengo duda en la número 17 o sea, del exam review número 1.
Mm-hmm.
No sé si la pueda discutir.
Mm-hmm. I'm just adding an extra sentence. If there's anything you want me to review, we can do that too. All right, so it should be the way I want it now. I added quantitative exercises with correct answers, but without evidence will receive a grade of 0. So you have to write me something, okay? Some evidence. Okay, so now you were saying in el 5,
Sí, en el exam review.
en el review, el número
El número 1, la 17.
17. Okay, let's give everyone a moment. You guys can try this one. Give me a few minutes and then I'll solve it together with you, okay? 17. And I can take a list like I did last time, a list of any questions you have or anything you want me to explain. I'm gonna upload, I'm going to show you my iPad. Yeah, you can put your questions in the chat. Sure, keep going. So like I said, any areas you want me to talk a little bit about? It's not clear. It's best if you can find a problem. Okay, so you see the exercise. Oh, what's this? That's not what I wanted. Okay. So suppose the variable z follows a normal distribution, and this is equal to 0.8. What does that mean? This p, what does this mean? Can you draw it? Okay, people are posting their questions. Good. So what does this mean here? Whenever you see the arrows going like small to big, you know, where they're open to the right and pointing to the left. So the symbol. What you're saying is the value here, the Z table or the Z, sorry, curve, you want on the Z curve, you want to go between, so this means between negative B and B. Now, since they're the same value, and since Z is symmetric, it means I am going to put them right around the center like that, because this is 0 here. This is B in the positive, and this is negative B, where this is the Z curve. And Z is, remember, normal with a mean of 0 and a standard deviation of 1. And we want to find the P, the probability in between there. So whatever the case, however it looks, let me do that again. Looks like a little off, but anyway, it should be even. Trying to make it. Oh, there. Okay, that should be even. And I want this. What's the chance of being between negative B and B? In other words, negative B standard deviations below and B above, or B standard deviations, or within, you could say another one, within B standard deviations. That's how we interpret on the Z, within B standard deviations, because on the Z, every value here is interpreted as standard deviations from the mean. Okay, we got the sign and we got the value. So what do we do? How would you like to do that? I mean, you can memorize certain ways of doing things, but it's better, I think, to draw it and then just have a couple of different things you could do. So you could tackle this different ways. This is 0.8, you're told. So like 80%. or I can put 4 to remind myself that when I use the tables, it's always 4 decimals inside the table, right? So what would you guys like to do? What's some options for answering this?
You need to take the 100% and subtract the 80%,
Okay,
divide it by 2, and look for that in the table.
okay. And honestly, you guys can feel comfortable to speak in Spanish. Don't hesitate to speak in Spanish. I'll understand. Okay, so I have to divide by 2. Why do I have to divide by 2?
Because you're looking at the corners, and you have one on the left and one on the right.
So this is known as the tails, right? On the side. Well, it's not exactly in the tail. Usually the tail is more like further out, but yeah, we're looking on either side. So 1 minus, so this is inside, and this is the 2 of them outside. So what do you get if you do that calculation? If you perform that calculation,
0.1.
point 1. And I'm going to just add more zeros to remind myself I have to look inside the table for that. Remembering the tables are always to the left. Okay, let's get that up too. So we can make it the table on one of these. So I have the tables at the top, so you could grab them at any given time. I put a few of things here. Why are the participation grades showing? This shouldn't show. It's weird. Oh, this is the old class, that's why. Okay. Anyway, it doesn't matter. I grabbed a different class. So it looks a little bit different, but anyway, they should be, where did I put it? It should be here. The top. Here. Okay, the tables are here. All right, so I look inside the table for 0.1, right? Where's 0.1? Remembering I'm looking, this gives me the area to the left. 0.1, the closest to 0.1 is this one, which corresponds to why can't I make it? Okay, so it corresponds to negative 1.2, and 8 is the second decimal up here. Okay, so 1.28 negative. That's important. And so B, or let's say you found negative V is negative 1.28. The question asked you to find B. The question asked you to find B. So what's the answer? You can put in the chat, or you can say
Okay, 1.28.
it's 8, right? So It's asking for B, it's not asking for negative V, but you found negative V, so then B must be 1.28. Just remember you solved it, make sure you solve it properly, but then answer the question. The question was not about a negative V, it was about B. So that's 1.28. The answer is A. Okay, next one, unless you have a question. Next one is, I'm going to take from Damaris 9 and 12. Unless anyone has any question, they want me to slow down. Oh, it's a nice one. I like this one. Very practical. I'm going to try and read the one at the top with the graphs. I'm going to grab some water. Be right back. Okay, how did it go? Comments? Let me start going through it. So I'll just display this one for now. So what do we see? The following figure displays 4 histograms or bar graphs without axis markings. They are the distributions for these 4 variables. So it's very important to be able to read data in a visualization, a graph or chart. So let's work through this. Number 1. Okay, so there are 4 variables, and you have to match the variables. The gender of the students in a class having somewhat more females than males, recorded as 0 for male and 1 for female. Which one could that be? There's just 2 possible outcomes, male or female. So you should just have 2 bars. So either it is C or D. They give you a hint that there are more females than males, and females will get number 1. That will be coded 1. So which one is it? You can put it in the chat if you want. Keep in mind that the number line here, like the from left to right on the horizontal, is a regular real number line. Negative values to positive values, right? So 0 is first, and then 1 comes next. So I agree with the chat that it's D. There's more women. Okay, so D is out. So we've got D done. All right, so let's continue with the next one. The height of the students in a certain class. So you have to think about what the values of the heights can be. Some will be, what did we talk about heights as a variable? Height is often symmetric. Most people are a certain height, some people are higher, just as many are lower than that height. And just a few people are much higher, but just as many are much lower. So it just balances out around the center. So which one does that look like? Right, B. So B is out. B is corresponds to number 2. So all we have are the 2 on the left. A and C are left. A and C remain. So number 3, the handedness of students in a class recorded as 0 for right hand and 1 for left hand. Which of those values will be more, will have a greater proportion? Or will there be more right-handed students or right-handed people than left-handed people? So you expect that it will be just a few with a 1 left hand. So sorry, it's there's just a few with a left hand, so I cannot highlight it. But above the 4, you see that there's just a few there. So that is the left-handed group, and the other one, 0, is coded for right-handed. And it's often when you're looking for something of interest, you give it the number 1 when you code, and the other one 0, if it's a binary, like 0, 1 variable or nominal variable. And that leaves us with A for the income of group of lawyers. Can someone tell me why? I mean, by process of elimination, A has to be the income of a group of lawyers, but we did discuss, or I haven't explained in the video, that income is often right skewed. Why is that? But there's just some conventions, that income is right skewed. How would you explain that? You can put it in the chat. It's not heavily right skewed in this drawing, but because lawyers probably all make a, relatively stable salary, but some lawyers make a very high salary, but few make relative to the rest. So in income in general, we talk about, or you hear about the 1%. What did I hear today? Like 90 families own 90% of the wealth of the United States, something like that. So very few are very high. Wealth is different from income, but just saying, income, if you think about people's income that they report, most people are run around some average or median, And then there's a few people who make a lot of money. So that's why those few extreme values. You hear about the 1% versus the 99% everybody else. Okay. So that's why. Did you need to know that, what I just said, to answer this question? No, because you can find the answer by process of elimination if you get all the others first. Should I write out the answer? You guys are good. I can write it here just to. So we said to review that A is 4. B is height. Height was 2. C was the left-handedness, which is 3. And I mean, the variable is handedness, which is a weird variable. And then, so I'll just call it hand. And then the last one was the remaining one, gender. And that corresponds with the answer option B. Okay. All right, let's see the next one. Let's see what's in the chat. Nine and 12. Damaris, is that okay? You got that one?
Yes, I got it. I wrote down the response.
Okay, good. All right, so let me let you read this one. These are kind of old problems, but the completion of the upcoming 2005-06 National Hockey League Scout plans to make a histogram of points scored in the season by veteran players. Those who have played in the league for several years or more. To prepare such a histogram, okay, think about that. Read that and think about that. How many of you have already completed the midterm review 1? Okay. That's good. We don't have too many problems from it, but hopefully this is just a review. Okay, some people did. Okay. All right, let's start for whatever reason. I don't know, the comprehension. Students have a lot of trouble with this question, this type of question. If you do all the reviews, you get an idea, or the 2 reviews and all my exercises, you get an idea of the pattern of the problems. And usually if you're making a mistake, you're making the same mistake. So give yourself enough time to review to be able to see your pattern, you know, where you're getting stuck, where you're having difficulty, and then I can help you resolve. After I post the test, you can't exactly ask me questions unless you're asking me directly about the test, but you have all the resources online to find my answers, okay? You have everything at your disposal. Don't wait until the last minute. My aim is that, you know, because I know everybody's busy and maybe there's some sections you didn't get to review well enough, and you can study them while you're answering the test. That's fine with me, but my goal is that you're actually learning in the process, so, and that you're taking something away from this class and not just learning it for the class. Okay, so to prepare such a histogram in which the bars correspond to each class are vertical, the horizontal and vertical axis would be, okay, so what you have to identify is what is the variable? What variable are we plotting on this histogram? Because histograms are always And it, does it say frequency or relative frequency? It doesn't specify, right? But so what is the variable that will be here? That's the question. Because in a histogram, on the vertical, what goes here always on the histogram?
Frequency.
Right. And frequency can be percentage of observations or the count of observations. If it's the percentage of observations, it's called a relative frequency. If it's the number of observations, it's called a frequency. And in statistics, they are not careful about saying one or the other, but if for your case, that's how you should refer to a percentage one. It should be called relative frequency, but often they just call them both frequency. So this one says, just make a histogram, doesn't even say the word frequency because it's testing that you know frequency needs to go here. So what is horizontal and what's vertical? Well, vertical, we already know should be percentage of, or the counts, percentage or the counts of observations. The horizontal is first, so that should be the variable. So if you look for the word count or frequency, you're down to B or C. So that helps narrow our options, right? Just trying to get it down. Anyway, you can see it's B or C. I can't get it to be both. Everybody agree so far? But it could also be points scored. That's also a count, isn't it? Years played is also a count. So I see it's getting confusing. All right, so it's getting confusing. Let's identify the variable. So what are we interested in? Let's read. We're interested in points scored in the season by veteran players. Okay, so yeah, this is tricky. So which one is going to be the variable? And what are we counting? Okay, let me see them. So you're telling me, tell me which one is horizontal? Or the variable, yeah. Which one's horizontal, the variable? Juliet says points scored.
Yeah.
Yeah,
Mm.
so it's so we're looking at points scored and we're counting how many of the veterans have that many points scored. If it's so, let's see if it's points scored. That's the only thing that makes sense, I guess, because we're going to put here it's kind of probably going to look like this, something like this, maybe, right? Because maybe even a gap. Because there's going to be some players that have really high scores, but most of them are like around here somewhere. And then you're counting how many players fall in each total. So your data is going to look like a list. I don't know names of hockey players. I apologize. I know I'm from Canada, but I don't know hockey player names. Wayne Gretzky, that's all I know. Wayne Gretzky. And then there was another guy. What was the other guy that everybody liked? Oh, well, anyway. So player 2. I'm making up names. And then you're going to have, so that's going to be that. And then you're going to have how many points they scored. And that's going to be your numerical data. you're going to have the histogram making like, this is going to be 50 to 75, 75 to 100, something like that. And then you're going to count how many of the players fall in each bar or each interval. And you could have hundreds of players, I guess, and then that will be, okay, so then you're going to count the number of players as counts. So horizontal will be points scored, and the vertical will be your counts. Okay, this is really hard, right? This is kind of confusing. Finally, I did it. So your variable will be the points scored, and you're going to count how many of the players fell in each of the intervals. All right, so it's confusing because both look like counting, but that's okay because they're both numerical, but one is counting the number of observations that fall in the certain intervals. So it's, I think the strategy is to find what you're trying to plot first. Horizontal. So, I mean, 80% of students get this type of question wrong, not to discourage you. I'm just saying it's common to misunderstand this. So practice is kind of a problem. There's several of them for you to practice.
I don't feel that bad then.
What's that? Oh yeah, don't feel bad. It's hard. It's hard. It's hard because they're both numbers. It's like, well, just try to remember what you're counting goes here. And what are you really plotting? Think about what variables that I'm looking at points scored, right? And then your count. So also the question, the way it's asked is very, it's kind of vague as well. I agree that it's a little vague. It doesn't go on and on to try and explain it as I am right now. But remembering, anchor yourself in the fact that the count of observations goes here, but you have to figure out what is your variable that you are sorting the observations into different categories. They're really getting sorted. And then you're counting how many of them fall in different intervals. All right, so that's not, don't feel bad, for sure. Okay, next. That was 12. All right, so I'm going to go to Jenny Smutty.
So it's B, the answer?
Oh, sorry. I say it is it right? Points scored and counts. Yeah, B.
Okay, thank you.
You can check. Let me know if I got it right. All right, let's see. Okay, we're going to stay on midterm 1 before I go to midterm 2. So I'm going to go to Eliximar's questions 11 and 28. So 11 is above. Okay, have a look at 11. I'm gonna be right back. Look at 11. So this sort of problem is a little tricky because you probably feel like, what are they talking about? What is all this terminology? I never saw this before. Which is the one that we learned about, we talked about? Which one looks familiar? I don't think I talked about pruning the stems. The one is D, right? Splitting the stems. Splitting the stems is when we make uh-oh. Putting me out. Hold on. When I begin making my stem and leaf plot, and let's say the data in this case is going to be between 18 and that's the minimum. Oh, no, it's not. What's the smallest value? They haven't even been put in order. That's
So the way I see it, you have two digits. So the last digit will always be the leaf. Therefore, the first digit will be the stem. And in that
Yeah, my
those
question-
options, the first
sorry.
digits are only 1 and 2.
Sorry, my question is, what is the minimum and what is the maximum?
13 and 26.
13.
Okay, that's what I wanted to say. So there, you have a bunch of data between 13 and 26. So it's very repetitive, right? It's a lot of data between 13 and 26. The range, if you calculate max minus min, is only 13, 13, a range of 13. And so we are going to represent the data. There's two digits like was just being explained, and we're going to use the first one as the stem, but we're going to also allow our intervals to go between 10 to 14 and 15 to 19, allowing all the values with 1 to begin with to have 2 or a split stem. Okay, so the first set of 5 can fall in this class, and the second set of 5 options will fall in this one. All right, so that's why it's called a split stem. And I do describe that I discuss making a back-to-back stem and leaf plot, split stem and leaf plot for Maris and Ruth in the data. The other things, pruning the stems, trimming the leaves. I don't talk about that much, but I think trimming the leaves refers to when you like if you have decimal data and it's just too repetitive, we just drop the decimals like we did with the spending data, if you remember. And we drop the decimals. Any questions about this? So it's the split. And in the notes, like I said, this is back in module 3, where I discuss the back-to-back split stem and leaf. Okay, next, unless you have a question about that. So that was 11 and 28. Okay, read that. So since there are 49 options, and you're starting with 1, 0, 2, 0, 3, there's 2 digits to the options. So you're going to pick 2 at a time. And as you do that, so you have 6, 6. So I'm going to take 2 at a time until I see any of these labels. Okay. So this is how the lottery works. Okay, so we found one that falls in the labels, 16. So 16 is chosen. So just with that alone, 16 is chosen. So A cannot be the answer because there's no 16 in A. B has 2 16s, but you can't take 2 of the same, so it eliminates B. You can have 2 16s in it. You can't repeat a number. They're unique numbers. Sorry, hold on.
1600.
Oh my goodness. Okay. So 16 is 1. Then there's 89. Okay, this is the next one. 8. Oh yeah, I was going through. So so A and B cannot be in it. C could be in it, or are we doing them in order? Which numbers would you choose for your ticket? Okay, so then 8. So 16 and 8 is in, okay, it looks like it's E so far, but maybe they're not in order of draw, so it could be C still. Okay, so we're down to C and D. But let's just continue. So that's 8. And then 4, 7, 7, 7, 2. And then 2, 1, 6, 5, 8. So just keep taking 2 at a time until you see your answer. Okay, 2 and 2, that's 22. So that's another one. So we have so far 16, 8, and 22.
47 is also an option.
Oh, 47. Yeah, I missed it. So they are in order. So then, so you see that E is the winner. 47. Yeah, it's tricky. 47 and 22. So they are being presented in order. Okay. Next, so I'm going to go to midterm 2. Oh, there's another midterm 1, question 18.
Professor, I had a question about that question that you just did because it said to the left or from the left, I think.
Yeah, we're going from the left, right?
So,
We're starting here and going like this.
okay,
That's what they
okay,
mean.
got it. Thank you.
Okay. Yeah. 18. I know I make things look easy. So you have to keep studying until it's easy for you. An instructor from the statistics department gives a 100-point exam for which the scores are approximately normally distributed with mean 70 and standard deviation 10. What is the minimum mark that a student needs to achieve in order to obtain an A+, and 10% of the students, if 10% of the students will receive an A+? So summarize that I am giving you I'm telling you a percentage and I'm asking you to find the grade or the mark. Okay. So the percentage I'm giving you is like information 10% get A+. Right. So that when I have a problem where I give you the percent, this is an inverse or a backward problem. So we have to perform the function, the calculations backwards. Let's begin by, it's also, I explained there's 2 steps in the process of thinking. First step is to draw what you're staring at. So what do I draw here? What numbers should I draw?
No, pero examen, presento ahorita.
Okay. So what number should I put there? You see, what's the number in the question? What number do you see in the question? What percentage? You see a few numbers, it's true. Right, you see the number 10%. So you got to think, where am I looking for that 10%? On the high side, or like on the right or the left? What am I interested in? What is the story here? I want to find who does really well. The 10% up here. That's where I want to draw it. And I'm going to draw it on the Z standard normal table. And then we're going to translate it because I know about the standard normal table, standard normal curve. I have information in a table. I actually have it programmed in Excel and everything. So I'm going to work with the standard normal table, and I want to find out, how can I be here? How many standard deviations am I from the 0 in the middle, mean, so that 10%, and I'm going to, because it's inside, I put the extra zeros in, 10% are above. So because the tables and even Excel only give you the left side, you need to translate that into 0.9000. Alternatively, you could just look this up in the table, but you need the drawing to remind you that if you look it up on the table is giving you the left side. And I explained last class and in some of the videos that if you change the sign, if you change the direction, you also have to change the sign. So you're going to see when you look this up, you're assuming that you're looking for the left side being 10%. You're going to get the negative version. You're going to get this over here. And then you have to change the sign to be able to talk about this one. So just keep it straight in your mind that the tables give you the left side. So I need to look up 0.9 on the table. And I know to go on the positive table by the drawing. I'm going to get the value closest to 0.9. All right, so which one is closest to 0.9? This one? So that one corresponds to 1.28. I feel like we saw this number already. 1.28. Okay. So that means that you have to be 1.28 standard deviations above the mean to be So 90% of the observations, 90% of students are less than 1.28 standard deviations from the mean. In other words, 10%, you're in the 10% of the highest grades, and these people get the A+. What if I looked up 10% on the negative table? What happens? So like I said, if I change the sign and I just, change the direction and look up 10% inside, this is the closest one here. It's negative 1.28. You see, it's just a negative. So if I'm going on the left side, I just have to remember that I have to flip. If I flip the direction, I also have to flip the sign. So it's giving me a negative, but I know it's 1.28. To ground yourself, always draw it. Let's do it in Excel as well. What will I put in Excel? So people who really like using Excel. How many people like using Excel? Is it popular here? I mean, for this class. If there's not too many, you don't have to. People don't have to use Excel. I'm just showing it as a, since we have the advantage of me giving you all resources for the test and things, so you can take advantage of Excel. It's not a requirement. It's just a tool for us. So what should I type in Excel to get this answer? I actually didn't finish answering the question. Let's finish answering the question and then we'll do Excel. Let's do that. Okay, so we didn't finish. We just did step 1. What's next? So now we have to convert that into this problem. This problem is actually all about grades that are normal with a mean of 70 and a standard deviation of 10. So what I need to do is convert, this is 1.28 standard deviations from the mean, but what does that mean in terms of the grades? That's just telling me the position. So I need to convert to X equals 1.28 standard deviations from the mean. You can remember that as a formula. You can remember that as the terms that I've just expressed in words. So you put in all the values. The mean is 70. Oops. The mean is 70 and the wrong way. See, I already messed up. The mean is 70 and the standard deviation is 10. And what is the answer? This is a multiplication here. You have to multiply those. 1.28 standard deviations from the mean. So 12.8 plus 70 is 82.8. The options are pretty close, so be careful with your calculations. So the answer is E. How's that? So how did I know to do this? I knew because the problem talked about a normal distribution. It gave me a percentage and asked me to get a grade. So when it's like that, when it's giving you a percentage and asking you for a score or X, some variable, you need to do the backward 2-step approach. Very good. Good. Okay, so I was saying Excel. Let's try an Excel. You guys can open your Excel. Why don't you try it without me? It'll be more helpful, more meaningful, more memorable. Okay, so I'm going to start typing norm. And which one do I pick? There are four. There was a few there. Which one do I pick?
Is it the norm.s.imb?
We could, but it's easier if we just pick inverse. Look, all I have to put in there, oh yeah, I have to put the probability. What's the probability that I put inside? Reminding you that Excel just gives you the left side, just like the table.
So the 90%?
Yeah, so it just gives you the left side. So you can put 90. And then you need to put the mean. What's the mean? 70. And the standard deviation 10. And that's it. Close it. And you get the answer. Isn't that nice? So it's a way you can check your answer without having the solutions. You can verify your answer. And if you get it wrong, you can think about, why did I get it wrong? What happened? And it can help you clarify about the table, about everything. Okay, wait, I always do that. Okay, so that's what you type. If you used S, what would you have to type? What would you put there? Does it change? It's asking for the probability. Do I put the same thing, 0.9?
Well, you need to standardize it first, right?
It's all, but if you use this, it's only going to give you part 1. So if you put 0.9 here, it's just going to give you the standard normal result, 1.28. So you still have to do the second step. So that's why I picked just inverse. It does the whole thing for me. Oh no, that wasn't it. Sorry. Why did it do that? So then you would still have to do the next step and multiply. So this is the better option. Does the whole thing for you. All right. What's next? Let's see. Okay, that's 18. Is that okay then, Jennifer? 18. She asked me to do that one. Okay, I'm going to go to review 2. Unless anybody has anything else on review 1, I'm going to go to review 2. So it sounds like you're doing either you're skipping the regression questions or you're doing okay on the regression questions, because no one asked me anything so far. How about regression? Review to 6/9/21/22. Okay. So 6. Okay, the standard deviation of ages in a family of 4 is 15 years. What will be the standard deviation of the ages in the family 10 years from now, assuming that the composition of the family remains the same? All right, so you got to think about your data. These are your observations. And then somebody is 40, someone is 22, someone is 15, someone's 50. We'll just say, how many people is he? Oh, we found 4. Okay, so it's only 4. Now, what's going to happen in, so you got the standard deviation from that, whatever data you calculated, n is equal to 4. Now what you're going to do is think about their ages in 10 years. What happens to the data? This becomes 50, 32, 25, 60. So the average will change because all the numbers changed, and whatever you do to the values, you also do to the mean. So if you change all the values by 10, the mean will also change by 10. And we're going to talk about this in the next module with probability. And rules for means and variances and distributions. So that's what you're going to see here. The mean is going to go up 10. But what will happen to the standard deviation? So let's see. Let me think about this. Let's think about it in general. Let's say I have a distribution. I'll just say it's symmetric. It doesn't really matter though. And then, so this is x, but then this is x plus 10. Or let me put it below. So let's say I'm going to add 10 to everything. So this is now x plus 10 on the same number line. It should be the same curve. Okay, wait, let me make it look like the same exact curve. Because it is the same curve. But I moved over 10. Is everybody following me? So this mean is here, but now the average will be plus 10. Did the standard deviation change? The spread didn't change at all. So adding or shifting a distribution doesn't change the standard deviation. So what does it say here? Okay, so what is the answer? It doesn't change. It was 15. So C is the right answer. 15 years. Questions about that? So shifting, adding a value to every, a number constant to every value of the distribution does not change the spread. It just changes the center. That's an important point. What will change the spread? If I multiplied every value, that will change the spread. But not adding, not shifting. Okay. That's one. I can make a note here. You're going to see it again. So whatever you do to every value, or every observation, of a distribution, you also do to the mean. And it's because the mean does not necessarily have to be one of the values, right? It's just us. It's a representation of being in the center. So all the other observations are closest to that value. So it's a representation of all the values. That's all it is. So if I shift, that shifts just the way that I'd shifted all the other values. Okay, let's go on to the next one that she asked.
Professor, if it was, as you mentioned, if it was multiplied, how will it change?
It will spread it out. So if I multiply by a number bigger than 1, you can look at it yourself, but if I multiply by a number bigger than 1, it'll shift, because it'll be times, it'll shift this over, but also it will spread it out, so it'll be flatter. If I multiply by a number less than 1, what will it do? Between 0 and 1, it will make it more narrow. It'll make the numbers smaller. So you have to think, I'm not going to talk about it right now because, anyway, if you just think about the same data set. So let's say we multiplied everything by 10. So this is 400. This is going to be 220. It's easier to do the math this way. 150 and 500. Obviously, these are not ages. We're just using the same values. And you see they're way more spread out. So the standard deviation, whatever the standard deviation was here, the standard deviation here would be 10 times. So it's bigger. If I multiply by a number between 0 and 1, then they're all going to be smaller and the standard deviation. So whatever I do to the values in terms of multiplying, I do the same thing to the standard deviation. But the shifting does nothing. Anyway, if this is beyond the test, but if I did this, I shifted and I multiplied, the 10 still does nothing. It's still going to be 10 times S is still this new standard deviation. The 10 does nothing for the standard deviation. It just does something to the mean. So we're going to talk about that more in the probability unit.
Okay, thank you.
So if you multiply by, if I take this, and I multiply by 0.5, this becomes 20, this becomes 11, this becomes 7.5, and this 25. The S, again, 0.5S, so it's smaller, it goes down. But otherwise, it'll go up. So we're going to talk about, like I said, more about that in module 6. And you have to talk about what if you multiply by a negative, what happens there. Don't worry about it for this test. Okay, so just to tell you, the main thing to realize is that the standard deviation, that if you add a value to every single observation, it doesn't change the mean. It changes the mean the same way that it changed every value, but it doesn't change the spread of the distribution by just shifting it. Doesn't change the standard deviation. Okay, let me see. So that was question number 6. What about 9? Okay, this is good. This is a drawing, so let's look at that. So when you make side-by-side box plots, you can compare them. You can compare the different groups. So let's just jump to 9. The following side-by-side box plot represents the percentage of single vehicle accidents involving alcohol in 90 jurisdictions for drivers in 4 different age groups. For the 25 to 29 age group, the distribution appears to be skewed to the left. Okay, so I did a discussion about reading box plots. It's a video in one of the V videos that are pre-recorded. And you can hear the cookie in the background. That was in 2012 when everything was much slower and I didn't have the facilities to do it all properly, but they're good videos and they took a long time to make, so I left them. But yeah, there's cookie in them. All right, so if I want to analyze this distribution, I'll try and replicate it here. That's even too much. All right, so what did I explain there? I said you have to look at the 2 relative quartiles. It's all divided into quartiles. 25% of observations are in each of these portions of the box plot. So between here and here, where the number line goes from 0 to the larger values, so small to larger values. It could even be negative here, but it's not in this case. From 0 to the larger values, it looks like that the data on the right is more spread out, so right skewed inside, but then I have to compare it to what's going on outside. On the outside, so these are the 2 extremes, or the first and last quarter. I compare the spread here and here, and I say, well, it looks like the right again is more spread out. So on the outside whiskers, or outside of the box plot, it's also right skewed. So that's how you analyze. In this case, now we're going to put it together. If both are right skewed, inside and outside, then it reinforces each other, and the data in that group are right skewed overall. The distribution appears to be skewed to the left. So A is not the right answer. Okay, it's not correct. The median is about 27. Do you agree with that? The median is this one here, because this is Q1, this is Q2, this is Q3, this is Q4. Oh, yeah. Q4 is the max. Yeah, that's the max. We just talk about the inside of the box, 1, 2, and 3, Q1, 2, 3. The median is about 27, so that's not true, right? Because this is not 27. It's like lower than 20 in that group on the drawing.
And from the plot, it's below 20, correct? Yes.
Yeah, it's below 20. And let me just make a point here that this is like being about here is 20, right? Somewhere about here is like 20. So no, it's not true. And then the mean is likely larger than the median. What do you think about that option?
Since it is right skewed, it will pull
Exactly.
the mean to the right as well. So then that statement applies.
Right. So the mean is pulled towards the extreme values on the right. Pulled in words I'm trying to say is away from the median, right? It's going to be pulled away. So the mean is likely larger than the median. Yes, that is the answer. Let's see. Let's keep going though. Let's keep going with the other options. So some students ask me, do I have to defend my answer, you know, disputing all of the options? No, but at least defend yours, okay? You just at least put a defense or choice, a reason for your choice. Oh, I didn't say that. The test is going to be all multiple choice, right? And it's almost like 4 or 5 from each of the different sections. Design and sampling, graphing and descriptive statistics, normal distribution, regression least squares. So you have 4 areas and about 4 or 5 questions from each. I think it's 18. I put 18. All right, next. Oh, let me go to the next one. All of the above or A and B only? Okay, so no. All right, is that okay now? All right. Janice? All right, 21. Okay, we have a regression question. Okay, read that one. Oh, let me just for a moment to get back to this one that we just did. So if you don't know what I'm doing here, go back and there's a video called analyzing box plots or something like that in GDS or in the module 3. In module 3, I have a video on it, how to interpret box plots. So do students who miss more classes get lower grades? Suppose that a random sample of 15 students is selected and the following output is obtained from the regression of final exam score versus number of classes missed. Which of the following statements are true? Since there are no students in the sample who missed exactly 8 classes, it would be inappropriate to use the regression line to predict the final exam score of a student who missed 8 classes. Is that true or false? Let's look at the output first. Let's see. So R square is equal to, on this output, 0.5952. So students often ask, what is an indication of a good fit? R square of like 60% of the variation is Y, and Y score is explained by X missed classes is not too bad. I mean, R squares you can see are very low. People publish quite low R squares. This is all right. What is the R, if that's the R square? We talked about this last class too. Make a note that the slope B is a negative. So B and R both have to have the same sign. So R will also be negative. And you can see that in the graph as well. It goes down. So what I have to do is take the square root of negative 0.5952, but also have I take the square root and have the negative in front. So when I do that, what do I get? What is the R? 77, 0.77. So what does this mean? Is this moderate or high? Moderate or negative? Moderate, that sounds weird, but yeah, negative, moderate, linear relationship, right? So it's pretty good. And because it's good, I can use the line to make predictions in the range of the data. The data for classes missed is from 0 till about 15, like probably 14, it looks like. Everyone missed a class except for one student. Okay, so from 0 to 14, so that's the range of X. That's the range of X. And 8 is in there. So since 8 is in there, you could use the line. So that first part is of A, that first problem is true. So that's not it. Everybody follow what I'm saying? So since 8,
So is A is false because it's saying that it's inappropriate.
it says, oh, since there are no students in the sample who missed class, it would be inappropriate. So this is actually, yeah, it's false because it says it's inappropriate. It is. So estimation should be fine. So is that it? That's not true. That's false. Okay, so B, we have to keep going. For a student who missed 30 classes, a good prediction of his or her final exam score would be 7.18. Is 30 far outside the range? We could say that's extrapolation, but let's keep going. That's an iffy one. Let's see what the options are. We have to pick the best one. The predicted final score goes down by 2.64 for every class missed. This is true. Since the slope is equal to negative 2.64. Is that the best answer so far? Where B is equal to change in Y over change in X. And we're saying this is classes missed. Score. Classes missed. That looks like the best one. Let's look at D. Based on these results, we can conclude that a student will increase his or her score on the final exam by attending more classes. How do you feel about that one? You say false because correlation does not imply causation always. Can't know that. I mean, people could be missing classes for reasons that are unrelated to their learning abilities. They could have different reasons for missing classes that are unrelated, although I do see that there is a relationship in my experience, but you can't say it causes them. So in the flip side, going to class is not necessarily going to give you a higher grade. doesn't cause it to happen. Is everybody okay with that one? You could just say there's a tendency for people who attend classes to also have higher grades. Or people who do not miss classes to have higher grades. It could be that they're just, you know, them being in class means they're more organized, they're on schedule, and all those factors that make them be in class are also influencing their performance in school and in this course. So that's not necessarily just going to class is going to affect things. It's just a proxy for a well-prepared student. Okay, E, based on the equation of the regression line, we predict that a student who doesn't attend class will receive a final exam for a score of only 2.64. Like, that's totally wrong. That's a misinterpretation of what the slope is. So the best answer, where I'm going to say that B, you shouldn't be making predictions outside of the range of data or too far outside. So we're going to say false for that one, and we're going to pick C. Is that the correct answer? It's just an interpretation of the slope. Okay, good. Okay, so I'm on, that was 21, now 22. Okay, one student missed 2 classes and received a final exam score of 84. What is the value of the residual for this student? Okay, so missed 2 classes. So missing 2 classes is like between 0 and 2.5. This is a weird table, but let me try and draw it. So you have 0 here, and then you have like, I guess that's 2.5, and you have 5, and then you have a value, let's say it has to be the one below for here. I guess that one's supposed to be 2. So there's a value like here. And the question is, the 2 classes missed and received a final exam score of 84. Oh, let me make sure that makes sense. Okay, well, that's not the data. Because over there, 84 is above the line. Oh, okay, so it's the one right above. That's what they're trying to get me to look at. There's one like right there. See that? Okay, yes, one student missed 2 classes, received a grade of 84. So we got for that person 284. What is the value of the residual for that student? So residual is equal to, so you can create yourself, you know, a set of formulas to study from. And one is to get the residual. You take the observed value for y, and well, actually, I write them like usually like this. So the y observed minus y predicted. So we do this calculation in the direction, the vertical direction. So the Y observed is 84. And where's the Y predicted? Predicted is always on the line, but right, above or below, wherever the line is. Right there. Okay, so I want to find, I made this circle so big. I want to find the distance between these two. So I'm going to make them smaller just so it's more realistic what I'm trying to do. So I want to find the distance between this point and this line. So I'm going to take, it's always in the order of taking the value of Y observed minus predicted. To remember that, I always remember that it's in statistics, we do things in alphabetical order a lot. So we take observed first and minus predicted. This also ensures that all the residuals above the line are positive because the values, the observed, are all above the line. So that the residual ends up being calculated positive if you're above the line. But it's going to be negative below the line because the predicted value is above anything observed below it. All right, so how do we calculate this? Okay, what are we missing? I have this, but I need this. So how do I get this? Well, it's on the line, so I need the line to predict it. So I can write Y hat or Y predicted. And how do I calculate it? I use the line. The line was 86.39 minus 2.64 times, how many classes? 2, right? Were missed. So what do you get for the predicted value? Okay, so you get 81.11. Now put that value over here. And what do you get? Positive. So the residual is anyone? Did you put it in the chat? I got 2.9. 2.89, or the answer is A, 2.9. Any questions about that? Okay, so you need to remember or put this formula aside for yourself. To get the residual, we always calculate the observed minus predicted. The observed was given in the problem. The data was given to you. In other words, if it's not given in the sentence, it's going to be given in the data set. And this is where X is 2 and Y is 84. That's what they're telling you. So then all you have to find is the predicted value and then get the residual. So the answer is A. So what you found out was the distance here between these two. All right. So that is question 22. Any questions about that? So I finished Jenny's Marie's questions, and then Fabiola asked me to look at 4 more. We have 4 more to go. If anyone wants to leave, you guys, of course, you can leave. But I'll just finish with these 4 and any other questions that you have. So Fabiola asked for 12, 30, and 38. Well, oh, that's a nice one, hey? So that's 12. 30 is, let's see, 30. Okay, and 38. Just having a look. Mhm. Ready? In a 3rd-year statistics course, there are 30 men and 20 women. In a midterm test, the average score of men is 66 and the average score of women is 70. Okay, what I'm referring to here in the notes is from module 3. Go to module 3. My discussion of weighted data or weighted averages. So that's what it's this stuff. This is what I'm getting you to do. So it's like this one, number 2, mean score of women, mean score of men. Okay, so if you want to see a video or repeat it, but I'll do this problem. But it's from here, page 23 in module 3. Page 23. I don't know why I did all that scrolling. So back to 12. So it says 30 men, 30 women. Okay, so average score. So average score for men was 66. Average score for women was 70. And what is the average score? So then N for men was 30 and N for women was 20. So how much in total are there in students? 50, right? So what I have to do is a weighted average. You guys want to try that by yourself first, or? It's more meaningful if you try first and I correct you, or you get it without me correcting you. So I've written it out to hopefully cue you that it's the weighted average. So you're going to take 30 out of 50 and do it like this, or I'll do it like this because that's how the other problem is. And that's for men. So that average is 66 plus 20 out of 50 for women. And that's what we calculate. Notice we could have used the average for 66 of 66 for 30 guys and the average of 70 for 20 women, get the total and then divide it by 50. You could do that too. So the average is used like I said before, it's the value closest to all the other points. So it represents them. So we can just use it and scale it to the whole class of men, and then this one for the women, and add the total score. So basically it's like the sum of all the grades, right? Divided by total number of students. What do you get? Actually, let me show you in the calculator too, how I would do that. Remembering in the calculator, I have my calculator in the proper mode. I showed you to make sure it has order of operations. So I'll just calculate it this way. And I could do 30, I could do even 3 out of 5, right? Because I could cancel the zeros or basically divide them both by 10. But anyway, I'll just do it like that. 30 divided by 50 times 66 plus, I can just keep going. 20 divided by 50 times 70. And that's the answer. So you can just go right through because of setting it up with order of operations. If you don't get that answer, you're having trouble with your calculator, let me know. We'll look at it together. We can do that now, or after this class, I have to, well, I guess I'll be around for a bit. But you can contact me by text, or yeah, text is best. And then I'll call you back, or we'll talk on text if you have questions. But I can't answer any study questions until unless it's before I put the test up. Okay, so that was 12. Fabiola, how was that? And
Yeah, that was helpful.
that's good. Okay. And then I'm just directing you that it's nothing new. You just got to see it's what we did before. It's the best way. Okay. So then 30. Oh, okay. So this one, so the discussion about correlation that I had with you, I talked about R more in a visual way. And if you have data like that, there is a relationship between the variables, right? But it's not a linear relationship. This is a curved relationship. Or they call it a non-linear relationship. That's a name for it. So this is why we have to plot, we have to visualize the data before we calculate any statistics. Because here you'll see there is a relationship, which is what you're really looking for. You're not exactly looking for a line. It's just that in this course, I teach you about the linear relationship and making estimates using the linear relationship. But what we're really looking for is relationships. We're looking for patterns. So there is a pattern here. It's nonlinear. If we didn't have the drawing, what would R be? Like if we just got it up, if we put the data into Excel or a calculator, we never looked at the data, we just punched it all in, what would R be? That's basically what I'm getting at here. So you need to think about this in the discussion that, using the discussion that we had before where I divided the data by its mean. This would be like the center of the data, or maybe a little bit more. Anyway, this is like the center, the balancing point. I'm going to put a few more dots just to make it more balanced. And oops. All right, so we have about the same. So that's dividing them in half. This is like the value closest to all the points in the X direction. This is the value closest to all the points in the Y direction. And remember the discussion that we had. This divides the data into two. And remembering, statistics is about averages and relative measures, right? So expected values. I've divided it into two now that everything's going to be relative to what we expect. The values above X bar are high, we'll call them, and the ones below X bar are low. The values below Y bar are low, and the values above Y bar are high. So I've divided the data into 4 different regions. So now we look for a pattern. When X is high, where is Y? Is there a distinct pattern? There's no distinct pattern. When X is high, Y is in both high and low quadrants in equal amount, right? When X is low, again, Y is in both. So what do I mean Y is in both? Let me just illustrate. So when X is here, somewhere here, where's Y? It's up here and down here. Kind of a little bit more up here, but that's just because I didn't put a dot down. I'll put one more dot there. I'm just creating this data set to make my argument. There, a little more balanced. All right, so that's kind of what you're staring at on the question 30. So what does this look like in terms of R? R is a measure of strength and direction of a linear relationship between two quantitative variables. The problem here is there's no linear relationship, so you really shouldn't be calculating R here. There's different kinds of measures to detect curves, but here R is not appropriate measure. But what will happen with R? If it's true that there's no pattern, R will just come up, even though usually we reserve it to talk about R being 0 when you see everything just kind of scattered around. Let me make this less bold. Usually I have mentioned, when the data is just scattered with no trend, it doesn't go up or down, just kind of scattered around. That's also R equals 0. So you'll get, if you don't look at this, if you don't draw this graph, this data will also have an R of 0. And it's because of the formula, the way it adds up. When Y is in both, you're not getting a distinct positive or negative pattern. And the R ends up being 0, showing no pattern. But there is a pattern, but it's not linear, is what you're basically getting. So the answer to that one is, I would say E, close to 0. And it's because of the way it falls everywhere. There's no distinct pattern. That's what will make it 0. And that's the same thing over here. Right? Same sort of outcome. Same equal balanced in the 4 quadrants. So that'll be close to 0 as well. So the takeaway is you always make a graph first. And even though I asked you to get the R for this, you wouldn't do that here in practice. You'd do something else to estimate this line, this curve, sorry, and use it to predict values that were not observed, that are close to the range or in the range of data. All right, so what else? 38, one more. Oh, nice. All right. So drugs are often used for reducing the blood pressure of hypertensive patients, those with high blood pressure. The following diagram pertains to an experiment that was run to investigate the effect of drug A or B and dose level, low or high, on blood pressure reduction. All right, so what do you think? What's going on here? Oh, there's a lot of terminology in this, I say a lot, but kind of very similar sounding terminology in the experiment module. So what you see is at the top, you see the same picture as you see at the bottom. Like this is repeated here. When you see a repeated experiment, it's pretty much blocked, okay? It's blocked. It's repeated with a different group, and that's the blocking variable. It's going to be blocked by hypertension severity. Okay, so when you see that, so what I mean by saying I see the repeat, basically everyone in the block gets all of the treatments. It's just repeated because you want to know how the treatments affect this group of people. You want to see how all the treatments affect this group of people. Right? So you block on a characteristic, not a random fact, like a randomization. You block on a characteristic that you want to isolate, because if you mix the mild hypertension with the severe hypertension, you risk that all the mild people will fall in a group, and then the results that you see are not due to the treatment per se, it's due to the fact that you have a bias in your group that people are mildly hypertensive. So you want to avoid that. So you divide them up, you repeat the experiment for everybody. That's blocking. So anyway, oh, I lost my page. I lost it. Oh. Maybe I'll do that. Oh, that didn't work. There. Okay. 38. So what are the options? Okay, so then it talks about, so it's either, in my mind, it's C or D. And it's one blocking variable. It's two, but it's two different groups, but it's one blocking variable. The block, so when we did men and women, the blocking variable was gender, but here it's going to be hypertensiveness or something like that, mild or severe hypertensiveness. So there's 4 factors or 2 factors. That's the question. Let me read the question. Okay. The following diagram pertains to an experiment that was run to investigate the effect of drug A or B and dose level, low or high. Okay, so what do you think the factors are? Again, think back to the discussion we had about aspirin Like that whole experiment where I started with the physician health study and talked about aspirin and beta carotene. So you had aspirin and beta carotene. I call that 2 factors, right? So drug A or B are 2 factors, but there's 2 levels. So there's 4 treatments. It's exactly like that physician health study where you had 2 factors and 2 treatments. So that's why you have 2 times 2 or 4 treatments. Sorry, 2 factors and 2 levels makes 4 treatments because it's 2 times 2. So it is 2 factors. Am I right? Is it D? Check the answer, Fabiola.
Yeah, it's
Does that make sense? It is confusing. So it's 4 treatments. That's why you have 4 groups of 4 bubbles in each block. Because it's 2 times 2. Think about the physician health study where you had beta carotene and aspirin, and then each had 2 levels, placebo or the actual drug. So we did 2 times 2 and got 4 treatments. That's why you have 1, 2, 3, and 4 here, and each repeated for a different type of. So this is a good question. It's not too hard, but it makes you think. Is that better? So when you see repetition, you know it's a block.
yeah, that's better. The part that was confusing for me was the treatments. Yeah.
Exactly. So treatments are calculated by the number of factors. So the levels of factor 1 times the levels of factor 2. Factor A has 2 levels, factor B has 2 levels, so it's 2 times 2. Okay, so yeah, that's good. It's a good question. It's not, like I said, not too hard, but it's using everything and it's still confusing enough to challenge you to think. Okay. All right, anything outstanding? Let's see. Some comments here. Okay. So shall we stop? If anyone has anything else about the notes, I'm gonna open it. Yeah, the exam will open at 1. So you guys can stay back and ask me now, or other people can go, or I don't know. Let me know if you need to talk to me more. If there's any question you have, I put the exam in Spanish and English. I have no idea how the quality of the Spanish translation. I had my TA edit them once, and I think I lost the file, or anyway, whatever. Let me know if there's any confusion about the questions. Just text me, send it to me, well, don't call me because usually I'm in the middle of something and then I won't answer. Text me and then I'll call you back. I have a busy schedule.
Profesora,
Sí,
¿puede discutir la 24 del exam review 1?
a 24.
Ajá, pero del 1, del exam review número 1.
Okay. Mm-hmm. Okay. A researcher wishes to study how the height of children during early adolescence is affected by milk consumption. She plots the height of children versus milk and decides to fit a least squares regression line to the data with X as the explanatory and Y as the response. She computes the following. So you have to carry out the steps. Uh-oh, something happened. I lost it. Sorry. What happened to my... sorry. I don't know, it's giving me a weird prompt. Oh, right, I need to do this. So you need to carry out the steps of getting the equation of a line, and the steps are, why do I feel like I did this? Did I do this last class? Maybe not. Maybe for my other group. Anyway, so the steps are, first, we know that X bar, Y bar must be on the line. That's step one. So what's X bar, Y bar? What's X and Y first to begin with? X is, so how do I know which one is X and Y? It's always Y versus X, or Y against X. So you're told to plot height versus milk, right? So that way you know that Y is height and X is milk. So now let's get the data. So Y is height and the mean height is 60. And X is milk and the mean milk consumption is 6.5. It's a lot. Anyway, 6.5. I guess if, wow, it's a lot of milk. Okay, so 6.5 and 60. Number two, calculate the slope. And you should put this on your formula sheet that you use. The formula is slope is R times SY over SX. What's R? R is the correlation, which is given as 0.9. SY is for height, remember? And X is 4 cups of milk. So the standard deviation of height is 1.2. You guys see where I'm getting the numbers, right? And milk is 3.6. Wow, so these are crazy numbers. I just realized how high they are. All right, so then that's it. Now I'll get B. And R is positive. So that it looks like people who drink more milk also are taller. It doesn't mean it causes them to be taller, but it tells us that they are more likely to be taller. It could have to do with a higher income. It could have to do with more education, knowing milk drinking is healthy. And those factors all contribute to being taller. But then there's genetic limitations, but we won't get into that. So this is not a causal relationship. It's just a correlation at this point. So it's not an experiment. This is just a sample that they've collected from observation of survey data. Okay. So what do you get for B? So you can really mess this up if you get Y and X mixed up. So you got to be, that's a really important start. Get X and Y figured out. And you'll do that by reading the problem carefully. So what is R? Not R, sorry, what is B? I got 0.3. So which ones have 0.3 as a slope? C or, well, it's just C, right? I don't even have to do anything else because it's just C. Because C says Y hat equals 5805 plus 3x. So I know this is the answer without getting the A because it's the only one with positive 3 as a slope. But let's get A just to feel like we can do it, right? How do we find A? Last step. It's a 3-step process. Find A, we put in, substitute the 1 point that we have. So Y bar again was 60, that's what we use this for. A is what we want, and then 3 and X bar is 6.5. So this, because X is closest to all the points in the X direction, or for the X variable, and Y is closest to all the values in the Y direction, they have to fall in the line because the line is the line that we choose is the one that fits closest to all the points. So this has to fall in the line. So we get to use it as a point, and then we can solve for A. So A is 60 minus 3 times 6.5, which I bet you, well, it's not. What's wrong here? 6.5, 58 should be a bigger number. Something's up. 3 is 0.3. Sorry, slope is 0.3 there. That fixes it for me. It's 0.3. Yeah. This is 0.3, 0.3, 0.3, and the answer is 58.05. Okay, so that you would have known the answer already because the only one with 0.3 as the slope was C. The other one, D, has a negative. It's not negative 0.3. So that's how you know. Okay. You guys just want to hang out with me, right? No one wants to leave. Anything else? Anything else you want me to review that you didn't really get, that maybe I can help you with before you get to the test? Any topics? No? Good. So you have everything available to you to study with, to work with. Don't spend 3 days on the exam. If you're spending 3 days on the exam, at least you'll be learning and studying at the same time. That's fine with me. But if you think that the exam should take 3 days, it shouldn't if you've been studying regularly. If you haven't studied at all, you take 3 days for the exam, that makes sense. But you shouldn't be taking 3 days for the exam. So you can enter and exit the exam. You can change your responses. And after you submit and after the deadline, you won't see your grades right away. I'm going to look at them first to make sure that there isn't anything. Anyway, for the grading scheme, I'm going to verify the grading scheme is correct, basically. And then you'll see the grades once I post them up. Some people have asked me for the participation grades. I still haven't done that, but don't worry, but I will get that done. People want to know if they have to come next week, I guess. So I'll do my best to get that this weekend. I intended to last week, but anyway, I'm in a class right now myself, and I have absolute mercy for students in distance classes when professors dump a lot of information on them and expect them to do it in one day. That's kind of what I'm dealing with. So I'm becoming humbled as a student again, consuming a lot of information online. But anyway, it's eating up a lot of time, and I'm spending like 3 times the time I should be spending on this course. It shouldn't be that time consuming. If you have an issue with the time that you're spending in this course, let me know. So maybe I can provide more direction. And anyway, let me know. Keep me posted. All right, I'm gonna let you go. I trust you guys are enthusiastic and you're gonna do your best. Keep me posted if you don't understand something. And you know, there's going to be a temptation to talk to each other about the problem, but don't rely on anybody else particularly because they could have the wrong answer. So make sure you do your due diligence, and you can only blame yourself if you get the wrong answer from somebody. All right. So make sure that you spend a good amount of time to build your confidence. And there's a lot of resources to help you do that. All right. Buenas tardes. Good luck. Unless you want to ask me something else, any other topics, let me know. I'll stay here.
Gracias.
I'll stay here if anybody wants to talk individual with me. I'll see if anybody stays back. I can turn the recording off.